Inside of .NET, there are 3 general-purpose delegate types that I use on an almost daily basis. These are func, action, and predicate. Let's look at action first. The action delegate allows me to type a variable that will be a delegate, so it points to a method, but that method has to return void. An action delegate always returns void, but it can take from 0 to 16 parameters. And the types of those parameters are determined using from 0 to 16 generic type arguments. In other words, an action of double, that first type parameter will type the parameter to the method. So an action of double is always a method that returns void, but it has to take a double. And that's a lot like the console write method that we've already implemented. It's a method that returns void but takes a double. And that print variable is now something that I can invoke and pass it a double value. That's syntactically legal. So it should be possible for me to just pass this to the dump method and have it use my print, except at the current moment, the dump method is using a custom delegate type, so I wouldn't be able to use an action, I'd have to use a printer. But now that we know about action, what I can do is replace printer with action of t. So an action of t where on an iBuffer of double, it would be an action of double, a method that returns void but takes a double. And that would work just fine for our purposes inside of the dump method. And you probably know that you can use a named method and assign it to a delegate. You can also write an anonymous method. So I'm going to write a method using the delegate keyword. This is a method that takes a double. And the implementation of that method is to just write line the data that comes in. And that's an anonymous method, so I wouldn't even need console write here. And in fact, you probably know that an easier way to express an anonymous method is to use a lambda expression in C#. So given a variable d, typed as double, because that's what action says, d goes to console.writeLineD. And if you've never been through that process before, watch my Link Fundamentals course. In the second module, I talk about how the features of the C# language evolved to support language integrated query, and I go into a lot of detail about delegates, lambda expressions, action, func, and predicate, all from a Link perspective. And certainly you've probably seen code, Link type code, that just uses inline lambda expressions. So when a method expects to take an action of double, I'll just define the lambda expression right where I call that method. And that's syntactically legal and it works quite well. So that's action. An action of double will be something like print that takes a double and does whatever it wants with that double, but it returns void. And then there's func. Func is very much like action in the sense that it can take from 1 to 16 parameters, and you type those parameters using generic type arguments. But there's always at least one generic type argument to a func, because a func always has to return a value, and the last generic type parameter that you give to a func is the return type. In other words, a func of double and double is a function that takes a double and returns a double. If it was double and string, it would take a double and return a string. But let's go with taking a double and returning a double. Mathematically speaking, I could do a square operation with that type of signature. So given a number d that's a double, I could return d times d and square it. I could also define a func of double and double and double. Remember, the last argument is always the return type, so this returns a double. Everything else describes the type of parameters coming in, so add would be something that takes 2 parameters, both of type double, and can return x plus y. And then there's also the predicate type. A predicate always returns a Boolean, so a predicate of double could be used to invoke a method that takes a double and returns a Boolean. So something like is less than 10 would take a double d and return d is less than 10. And now I have 4 variables, all delegates, so I can invoke them. And I could do something like, let's add 3 and 5. In fact, let's square the result of that. And then let's see if it's less than 10. And then we could print the result of that expression. And once again, the C# compiler can jump in and say, well, wait a second, is less than 10 is a predicate. Predicates always return a Boolean. You're trying to pass a Boolean to an action of double. So if I really want to print this Boolean value, not a double value, then I could have an action of bool. And if I run this, we get the output right away because that's before I even try to process input for the buffer. So of course that comes out as false because squaring 3 plus 5 is much more than 10. But these action, func, and predicate delegate types, extremely useful. In fact, all of the link operators, pretty much all of them take funcs of different types. So if you're using where, order by, select, join, group by, all of those wonderful link operators that operate on IEnumerable of T, all of them take funcs to describe how to sort something, how to filter something, how to select something. You write little lambda expressions to describe how to do that processing. And that's all in my link course if you want more details about how to work with func and IEnumerable of T and iQueryable of T. I just wanted to give you a refresher on these. And now there are also some additional delegates that are available in the .NET framework. Ones I don't use every day, but there's one in particular that we can find useful for our application.